All right, welcome back to the Enhanced Integrated 2 semester final review. This table represents a survey about whether boys and girls have received a speeding ticket. And so first let's familiarize ourselves. So the total surveyed was 66. And if they're asking me for conditional probability, I will be dividing by either these totals here, or by these totals right here, depending. So only in conditional probability, otherwise I will be dividing by 66. What is the probability of selecting a student that has had a speeding ticket? Write as a simplified fraction. So a student that has had a speeding ticket, so that would be speeding tickets out of everyone. So there's no conditional probability, it just says that a student has had a speeding ticket. That means any student. So that would be the probability of S for speeding ticket, which is 10 out of 66. And it does say to write it as a simplified fraction, right? So 10 out of 66 have had a speeding ticket. So 2 will go into both of these. 2 divided into 10 is 5, and 2 divided into 66 is 33. So this is 5 out of 33. What is the probability of selecting a student that is a girl? So now they're conditioning something that is a girl and has not received a speeding ticket. Write it as a simplified fraction. So this one, actually they're not conditioning it because it says and has not received a speeding ticket. So they're asking for the probability that the student is a girl and has not received a speeding ticket, so speeding ticket complement. And it says to write it as a simplified fraction. And so we're going to divide by everyone because this is not conditional probability, so 66. And then girl and speeding ticket complement would be no speeding ticket and a female, which would be 25. So 25 out of 66, that does not reduce, so we'll leave it as 25 out of 66. Again, for just a moment, I thought it was going to be conditional probability, but then I realized they used the word and. Now, if they had said here, a girl who has not received a speeding ticket, I know that seems really, really sneaky, but a girl who has not received a speeding ticket is conditional probability. So we will not put anything tricky, like vocab-wise, on the test. We'll make sure that it's really clear and we use something like given that. All right, and it says, what is the probability of getting a speeding ticket given that you are a boy? So my denominator is going to be out of the boys. So I'm going to be only looking at this row. So out of the boys, which is out of 44, is the probability of getting a not getting a speeding ticket given that you're a boy. So out of the boys, which is 40, not 44, I'm sorry, out of 40, they have not gotten a speeding ticket, which is 31. And that is already in simplified form. It's 31 out of 40. And now they ask us again about mutually exclusive and independent. So I hope that we know at this point that mutually exclusive, look at your table. These all have somebody in them, right? None of them are empty. That means that they can both happen at the same time. So they are not mutually exclusive. So I'm already going to take off. It says the events are both independent and mutually exclusive. No, they're not mutually exclusive. It says not mutually exclusive. It says they are mutually exclusive. No, they're not. And it says they're neither. So we're going to leave B and D. Now we need to check, is the probability of being a boy and getting a speeding ticket an independent event? So I would say they're not independent. I would think boys are more likely to get speeding tickets because they're a little riskier, but we have to check mathematically. Does the probability of being a boy and getting a speeding ticket equal the probability of being a boy times the probability of getting a speeding ticket? So again, no conditional probability here. The only one that's conditioned is this one. So we're going to divide by everybody. So out of 66, the probability of being a boy and getting a speeding ticket, boy and speeding ticket, is 9, right? They get a speeding ticket and they're a boy. And is that equal to the probability of being a boy? The probability of being a boy is, 40, right? 40 out of 66. And then times the probability of getting a speeding ticket, which would be 10 out of 66. And now I'm going to do some calculator work. So 9 divided by 66 is 0.136. 40 divided by 66 is 0.606. And 10 divided by 66 is 0.152. And so I'm going to multiply 0.152 times 0.606. So I get 0.136 is equal to 0.092, which is not true. If these are not equal, then they are not independent. So they are neither. They're not mutually exclusive, nor are they independent. The answer is D. Now, just because they were not either on the reviews does not mean that that will be the case on the test, so you do have to check. And we have one more probability problem using a Venn diagram. Let's go ahead and illustrate. This is probability that you play an instrument, and this is the probability that you play a sport, and this is the probability that you do both. Right, so you're both playing a sport and an instrument at the same time. So what is the probability of S? So where S is sport. So the probability of S is all of this circle, so 0.29 plus 0.23. Now they've already given it to you as a decimal, so you do not, as a fraction, not a fraction, I'll try it again, as a percent. So 29% plus 23%. And it says write your answers as percentages. So you don't have to change it into a decimal. I just prefer to when I'm doing it. So that would be 0.52 or 52%. So 52%. What is the probability that you play an instrument? So that would be these two together, which is 23% plus 10%, or 0.23 plus 0.10, which is 0.33. 33%. And then it says, what is the probability that you play a sport or an instrument? So that would be 29% plus 23% plus 10%. So 0.23 plus 0.29 plus 0.10. Or you could just take the entire circle, or the outside area, and minus that from 100%. Either way, when you add these up, or when you subtract this from 100%, you're going to get 62%. All right, that is all on probability. So I did give extra probability problems. There are only 2 probability questions on the test. So there are 2 probability questions. One with a Venn diagram, and one with a two-way table. I gave you several of each, so I believe I gave you 3 of each kind. I thought I had only given 2 of each kind, but 3 of each kind because that was the area that students struggled with the most at the beginning of the year. And so I really wanted to make sure that you had plenty of practice. So you definitely have to know the 2 rules I talked about: mutually exclusive and independent. Okay, so you need to know those for sure. They are on the test. All right, find the value of R. Do not round your answer. So we have similar triangles here. The reason these triangles are similar is because they both have a 90-degree angle and they both share angle C. And so by angle, the triangles are similar. Right? They have 2 corresponding congruent angles. So I'm going to draw them out separately. Here is the smaller triangle. This is triangle D, B, C. And here's my larger triangle. This is triangle E, A, C. And I'm going to go ahead and label what I know. So this entire base from C to E is 64. And the base from C to D is 40. I don't care about this 24 yards, but you notice that if, for example, they hadn't given me this, like let's say this was blanked out and I didn't know it, I would need to find it, right? And that would be why that 24 would come in handy, because I could take the entire length, 64, and subtract 24, and that would give me that length. All right, they tell me that this is 19.5, and then this is my unknown R. So I'm going to create a proportion. So corresponding pieces go together. So you can say 19.5 is to 40 as R is to 64. Or you could say R is to 19.5 as 64 is to 40, and so on. I'm going to use always side is to base as side is to base. We're going to cross multiply, or you could multiply both sides by 64. It's up to you. I'm going to go ahead and cross multiply. So I'm going to write that again. So 19.5 over 40 is equal to R over 64. Cross multiply, I get 40R is equal to 19.5 times 40. You are allowed to use your calculator. That's 780. And then I would divide both sides by 40. R is equal to 19. Oh, I multiplied that wrong. I'm sorry. 19.5 times 64. 19.5 times 64 is 1,000. So I have an error here. My bad. This should be 1,248. Divided by 40 is 31.2 yards. So 31.2. And it says do not round your answer. All right, moving along. It says that the triangles are similar. So we're guaranteed that they're similar. It says find the length of EC. So this is my unknown. So I'm going to say top is to side, 12 is to 8, as X is to 16. Some of us can do that in our heads. Like I can see it's 24 because this is twice as big. This must be twice as big. But you can cross multiply. If you're stuck, you get 8X equals 12 times 16. I think that's 144. No, 192. Divided by 8. And it's amazing. X is 24. All right, so this one, they have separated them out for you. In this one, they were kind of compounded triangles, so you notice I drew them separately. So don't make a small error by using something like 24 and 40 instead of using 64. And another thing is, I mean, logically, look at this. If you had used 24 here instead of using 64, you would have gotten an R that's smaller than 19.5. That can't happen, right? This R has to be larger than this side right here. Okay, let's move along. Similar triangles again. So you're going to have one question on similar triangles. You were given 2 review questions. Here's another similar triangles question, but this is a application problem. So it says a student and a flagpole cast a shadow at the same time of day. Well, then they're guaranteeing you, right, that there are similar triangles because those angles of inclination will be congruent, and these are going to be 90-degree angles. And it says find the height of the flagpole, X. And so we're doing the same thing again. We're setting up a proportion. Now, if they don't give you a picture, make sure you draw a picture. So always draw a picture if you're not given one. But we're given one. So in this case, we're going to say X is to 84. Right. Side is to base as side is to base. 5.4 is to 9.2. And we're going to cross multiply. So I get 9.2x is equal to 84 times 5.4, which is 453.6. And then I'll divide both sides by 9.2. And I get 49.6 49.3. And it says to the nearest tenth of a foot, 49.3. Now the next digit was a 0. So rounding to the nearest tenth of a foot. Number 10, again, so you're going to have one that's a regular similar triangle problem and then one that's an application. And again, if they don't give you a picture, please make sure that you draw it. A person and a building cast a shadow at the same time of day, guaranteeing you that these are congruent and that these are congruent. Therefore, the triangles will be similar. It says find the height of the building, X. Now you notice this time they did tell you the person is 5.8 feet tall and cast a shadow of 3.2 feet. So if they did not give you this picture, you need to draw it. And then the building cast a shadow of 28 feet. So height is to base, or height is to shadow, as height is to shadow. So we get 3.2. X is equal to 28 times 5.8, which is 162.4. And then we'll divide by 3.2. So the height of the building is 50.75. And it says to the nearest tenth, so 50.8. What is the measure of the missing angle? Round to the nearest whole number. Let me check the time on the video. Okay, we're good. I like to try to keep my videos at about a half an hour max. So, all right, whenever you're missing two angles or missing two, oh, well, first you have a right triangle, okay, and you're missing two angles or missing two sides, you're always going to use SOHCAHTOA or trig. Whoops, SOHCAHTOA. Let me use my whiteout here. All right. So we're going to have to use, we are missing two angles, right, in a right triangle. So we're going to need to use either sine, cosine, or tangent. Now, another important thing to know is in a right triangle, wherever the right angle is, if you follow it out, this will be your hypotenuse. That will never change. Your angles, opposite and adjacent, those could change depending on which angle you're standing at. So like right now I'm standing here at this angle. So opposite this angle would not be this side, nor this side. These are touching the angle. They're called adjacent. So one of these is the adjacent side, and one of these will be the hypotenuse. That means the opposite side must be the one that's not touching it over here. So I know I need to use everything except for the hypotenuse because the hypotenuse doesn't have a value on it. And you notice that sine uses the hypotenuse and cosine also uses the hypotenuse. So I'm not going to be using either of those. I'm going to use tangent because I'm not given any information about the hypotenuse. And so my tangent ratio, right, is we always write tangent of the angle is equal to the opposite over the adjacent. And now you don't have to use x to represent the angle. You could write angle here. In fact, usually I do write tangent of the angle is equal to. Now here's where I saw a lot of people, you don't want to set up equations. That's not going to get you very far in Math 3. I was just giving the review for them, and they'll have just like what would let you solve it, and it'll say something like tan inverse 12 over 20. So if you can't set up the equation, just knowing how to type it into your calculator won't help you. All right, so the angle in this case is x. So tangent x equals opposite. Opposite is 12 over adjacent. Adjacent is 20. And remember, my goal is to get x by itself. The opposite of tangent is tangent inverse. And if I do that to one side, I have to do it to the other. And so I get x equals tan inverse 12 over 20. Now, on your calculator, you're going to do second tangent because you want tangent inverse. So whenever you're looking for the angle, you're going to be using tangent inverse on your calculator. And that's 12 divided by 20. And I get 30.96. So I think it says to the nearest degree. Yes, the nearest whole number. So that would be 31, and it is in degrees, so 31 degrees. All right, let's do another one. I'm actually going to skip 12 and go back to it because this one has to do with sine, cosine, and tangent. So let's go ahead and go directly to this one. So I'm going to write my SOHCAHTOA down so I don't forget. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the first thing I'm going to do is identify my hypotenuse, because this side, the hypotenuse, will never change. Now my opposites and my adjacents, those can change depending on if I'm using angle A or if I'm using angle C. If I'm using angle A, then these are the adjacent sides. This one's the hypotenuse and this one's the adjacent. But if I'm using angle C, these are my adjacent sides. So now this one would be adjacent and the other one would be opposite. So you need to know the difference between using angle A and using angle C. All right, so the first one says sine A. So sine A is equal to, right, opposite over hypotenuse. So I know the hypotenuse is 5 no matter what. And then sine A means opposite. So opposite of A would not be this side. It would be across from A, 3. So I would write 3 over 5. And it says use a slash. Okay, the next one, sine C. Well, now if I'm standing at C, right, opposite of C, so sine C, is still opposite over hypotenuse. So my hypotenuse is still 5, but opposite from C is over here, it would be 4. So 4 over 5. And then cosine A. So cosine A is adjacent to hypotenuse. Cosine A, adjacent to hypotenuse. So again, my hypotenuse is still going to be 5, but adjacent to A. So if I'm at A, adjacent is right here, 4. And then finally, cosine C, still adjacent to hypotenuse, so still my denominator will be 5, but adjacent this time is right there, 3. And so what you should notice is that sine A and cosine C are the same thing, and that cosine A and sine C are the same thing. All right, let's go back to the simplifying the radical. So simplifying radicals, we're going to multiply coefficient to coefficient. So this is going to be 2 times 3. And we're going to multiply radicand to radicand. So that would be square root 3 times square root 15. All right, so we're going to multiply 2 times 3, that's 6. And then we're going to have a radical, 3 times 15. I'm not going to multiply it out. I'm going to leave it as 3 times 15 because I might have to simplify this radical. And I will have to simplify that radical because that radical has a perfect square in it. And so this would be 6 times the square root of 3 times 3 times 5. 3 times 5 is still 15. And I see that here's my perfect square. It's going to come out, right, 3 squared. The square root of 3 squared, or the square root of the square root of 9 is 3. And so the 3 is going to come out and multiply with this 6. So the 6 stays, the 3 is coming out, and then under the radical is that lonely 5. That would be 18 square root 5. So 18 square root 5. Let me check the time again. We still have some time, so I'll keep going. All right, we have more trig, sine, cosine, and tangent. All right, so it says use a slash to separate. First, let's identify. This is always going to be our hypotenuse. And now I'm going to identify if I'm standing at angle Y. Here's my adjacent and my hypotenuse. So this will be adjacent. If I'm standing at angle X, here's my adjacent. If I'm standing at angle X, opposite will be across from it. If I'm standing at angle Y, opposite will be across from it. All right, and then I'll write my SOH, CA, TOA so that I know my trig ratios. All right, so sine x, so if I'm at x, sine is opposite over hypotenuse. At x, the opposite side is 9 over the hypotenuse, which is 15. So 9 over 15. And it does say, it does not necessarily say to simplify it, but I'm going to go ahead and say if it doesn't say to simplify it, you could leave it. But if it asks you to simplify it, since it could, I'm going to go ahead and divide all of this by 3. 9 divided by 3 is 3. 15 divided by 3 is 5, so 3 over 5. It could ask you to simplify or not. So it might take 9 over 15. It might ask you for 3 over 5. Okay, next one. Sine, again, is still opposite over hypotenuse. In this case, the opposite, if we're at angle Y, opposite is over here at 12. And these still divide by 3. And so this is the same thing as 4 over 5. Cosine of x. So cosine is adjacent to hypotenuse. So again, my denominator is 15, but my adjacent at x is 12. And that's going to reduce to 4 over 5. And so what we should notice is that sine of x and cosine of y will be the same thing. Well, if I know that, I can just go ahead and say sine of x and cosine of y will be the same thing. So sine of y, cosine of x, and sine of x, cosine of y, they're the same thing. So this is going to be 3 over 5 as well. Tangent. So tangent is opposite over adjacent. If I'm standing at x, opposite is 9. So opposite over adjacent. Opposite of x is 9. Adjacent to x is 12. And I would reduce those by 3. And I would get 3 over 4. And then actually what happens from tangent x and tangent y is that they're reciprocals because we have opposite over adjacent, but if we're standing at y, opposite over adjacent would be 12 over 9, which is 4 over 3. And so tangent from the two angles flip-flop. All right, in the following figure, the value of x is, all right, so I'm going to go back to what I said before, right here. In a right triangle, we're missing 2 angles or missing 2 sides. We have a right triangle, and we are missing 2 angles? No. We're missing 2 sides? Yes. We're missing 2 side lengths, so we have to use sine, cosine, or tangent. So we're going to use SOH, CA, TOA. We have to pick which one. We're given the hypotenuse, so we will not be using tangent. Now, really, we could use either sine or cosine, because I could use this angle if I wanted, but I'd have to calculate it, right? I'd have to subtract to find it. I'd rather just go ahead and use the angle they gave me, which is angle C. So if I'm standing at angle C, I would have adjacent and hypotenuse, so I will use cosine. So cosine of the angle is equal to adjacent over hypotenuse. Now this time we're given the angle is 41 degrees. So cosine 41 degrees is equal to adjacent, which is our unknown, over the hypotenuse, which is 11. And then I would multiply both sides by 11 in order to get x by itself. So I have x equals 11 times cosine 41 degrees. And now I'd need to use my calculator. So 11 times, I'm not going to use inverse, right? I'm not looking for an angle. I'm given the angle is 41. And that's 8.3. And it says round to the nearest tenth, and I already did. So 8.3. All right, so we have some more trig. We're at about 29 minutes, so I'm going to stop the video here and go to the next video.